Hey guys, welcome back to Matthew's Ballistics. Just got off work a little while ago. It's pretty late, but I'm gonna get y'all into what I'm working on tomorrow here real quick. All right, so I'm comparing a 300 grain lead cast bullet, which from a Lee mold is supposed to be 300 grains with pure lead. However, I cast them with linotype, so it's got a little less lead in it and a little more of some other metals, and therefore it actually weighs a little less than 300 grains. It casts out about 295 grains, and I'm comparing that to this 300 grain Alco bullet. Now, I've shot at these in the past, and I've shot them for accuracy and whatnot. But I never really had a great way of testing um, the ballistic coefficient difference of these bullets. So on paper, if I've got a 100 yard zero, your 300 grain Lee bullet here, from my rifle going 2100 feet per second, from 100 yards to 200 yards, it's going to drop 9.6 inches or 4.6 MOA. And at that distance, it should have about almost 1,500 feet per second and about 1,460 to 1,465 foot-pounds of kinetic energy. And then going to 300 yards, it's going to drop 34.9 inches or 11.1 MOA. And it's going to be going about 1,262 feet per second and have about 1,050 foot-pounds. So compare that to this, and that's with a 0.233G1 ballistic coefficient. Now on Alco Bullet's website, they list this as having a 0.485G1, and so what this means is it's a much more aerodynamic and much more efficient bullet at going through the air. So with it loaded to the same specs, 2,100 feet per second from the barrel of my gun, it's at 200 yards, it's going to have 7.7 inches of drop. So that's roughly 2 inches less drop compared to the 300 grain linotype cast from the Lee mold. So it's about 3.7 MOA. So is already a pretty good difference there in the drop. But also, by calculation, it should have almost, or right at 1,790 feet per second and still over 2,100 foot-pounds of energy, almost 2,150 foot-pounds of energy. So we're looking at, compared to that, up to that, at 200 yards. And that's just because it's more efficient flying through the air. Now at 300 yards, it's going to have 26.9 inches of drop, or 26.4 inches of drop versus the 34.9. So it's about 8.5 inches less drop at 300 yards, which is 8.4 MOA compared to 11.1 MOA. And then the energy retained is 1,649 feet per second and 1,811 foot-pounds. So about 80% more energy than the lead cast bullet at that distance. So on paper, it looks like this is going to be much better round shoot. The ballistically, calculations and everything, it's a much more efficient, much more powerful round out to distance. So tomorrow we're going to test this. I've got a bunch of these. I've got a bunch of those, and we're going to shoot them. I'm going to first zero the gun with this at 100. I'll shoot 5 shots, and then I'll take it to 200 and shoot 5 shots, and 300 and shoot 5 shots. And I'm going to measure, and I'm shooting them all on the same target. So I've got a really tall target that I should be able to catch all the rounds on at different distances, and I'll be able to measure and see how exactly how much drop there is. And I'm going to do the same thing with the Alco bullet, and then we'll compare and we'll see how close it is to the published ballistic coefficients that they have. Now, at different altitudes and whatnot, you're gonna have different values. So where I'm at, I think I'm roughly 500 feet above sea level. So we're gonna see what values I get at where I'm shooting. Now, if I was shooting, 5,000 feet above sea level, or 10,000 feet above sea level, or 500 or 600 feet below sea level, I would get different values. So this is just going to be out of my rifle, where I'm located, and how, exactly my rifle is shooting these. So hope you guys stay tuned. I hope you guys get ready to check this out tomorrow. Hopefully I will have the video up tomorrow late afternoon of the actual testing and shooting. But anyways, we'll see you guys tomorrow, and we'll see you in the next video.